All right, this is Unit 4, Lesson 4, Adding and Subtracting Rational Expressions. Our essential question is, how do you rewrite rational expressions to find sums and differences? Here is our table of contents. Add rational expressions with like denominators. So when I'm adding rational expressions with like denominators, it's the same as if I were adding normal fractions. I'm going to add my numerators together and keep my denominators the same. So what is the sum of x divided by x plus 4 plus 5 divided by x plus 4? See if the denominators are the same. They are. So I just add my numerators together. I get x plus 5. I can't combine the x and the 5 because they are not like terms. I then see if I can factor anything out of this. In this case, I cannot factor anything, so that is my answer. X plus 5 divided by x plus 4. What is the sum of 2x plus 1 divided by x squared plus 3x 3x minus 8 divided by x times x plus 3? I want to see if the denominators are the same. Glancing at this to begin with, the x squared plus 3x and the x times x plus 3 don't necessarily look the same. So what I need to do is I need to see if I can factor one of those denominators in order to see if they are similar, the same, or if I'm missing a component. Okay. The x squared plus 3x, I can factor out an x. So I get x times x plus 3, which gives me the same denominator as my second fraction. Since they are the same denominator, I just add my numerators together. 2x plus 3x is 5x, and 1 minus 8 is that minus 7. Okay. I then see if I can factor anything out of this. In this case, there's nothing else that I can factor, so I'm done. Okay, so my final answer is 5x minus 7 divided by x squared plus 3x. You can also leave it as 5x minus 7 divided by x times x plus 3. Either answer is correct and will be considered a correct solution. Identify the least common multiple of polynomials. How can you find the least common multiple, or LCM, of x plus 2 squared and x squared plus 5x plus 6? So the first thing that you want to do is you want to factor these polynomials out. X plus 2 squared is really x plus 2 times x plus 2. X squared plus 5x plus 6. I'm looking for a number that multiplies to get me 6, but adds to get me 5. In this case, 3 and 2 multiply to get me 6 and add to get 5. So that gives me x plus 2 times x plus 3. Now I'm looking for what's the same and what's different. They both have an x plus 2 in common. The first one has an additional x plus 2, and my last one has an x plus 3. Okay, so when I write the LCM, I combine the double, right? So that's the x plus 2. I have an additional x plus 2 in the purple and an x plus 3 in this pale yellow. So x plus 2 times x plus 2 times x plus 3 is my LCM. So in this case, I'm going to rewrite it as x plus 2 squared, because I have 2 of them, times x plus 3. How can you find the least common multiple, LCM, of x cubed minus 9x, x squared minus 2x minus 15, and x squared minus 5x? You do the exact same steps as you did in the previous example, okay? X cubed minus 9x gives me x times x squared minus 9. X squared minus 9 is the difference of perfect squares. So that's x plus 3 times x minus 3. X squared minus 2x minus 15 is x plus 3 times x minus 5. And x squared minus 5x, I can take out an x. So I get x times x minus 5. And looking for what's same and what's different. My first and my third have an x. My first and my second have an x plus 3. Then I have that x minus 3 at the top. And then my second and my third have an x minus 5. Okay. So my LCM is x, because I have this one grouping of x plus 3, the yellow, x minus 3, the purple, and x minus 5, the gray. So that's the LCM of those three polynomials. Add rational expressions with unlike denominators. So just like with fractions with unlike denominators, you have to find a common denominator in order to add or subtract these fractions together. So if I have x plus 3 divided by x squared minus 1 and 2 divided by x squared minus 3x plus 2, I'm going to factor the denominators first. X squared minus 1 is the difference of perfect square. Okay, so that's x plus 1 times x minus 1. X squared minus 3x plus 2 is x minus 2, x minus 1. So my LCM, right, I have this x plus 1. I have the x minus 1 here in both my numerator and denominator, so they're just 1. And then I also have that x minus 2. Okay. So multiply the LCM by each of the fractions. Okay, so I'm multiplying this entire LCM by my fractions. So if I'm looking at my first one, I have x plus 3 over x plus 1 times x minus 1. So really I'm multiplying by x minus 2 in order to get that denominator to be the same across both of my fractions. Okay. Same thing with my second fraction. I'm multiplying my numerator and denominator by x plus 1 because that's the part of the LCM that was missing. Okay. I can add my numerators together, leave the denominators alone. So I get x plus 3 times x minus 2 plus 2 times x plus 1. I want to go ahead and simplify my numerator. And you get that by FOILing this set of polynomials. So remember, I have the x times x times -2, 3 times x, and 3 times -2. And I'm also distributing this 2 to everything that's inside the parentheses as well. So that's where I'm getting these values from, okay? From this first fraction, I'm going to go ahead and simplify by combining my like terms. I've got an x squared by itself. 3x minus 2x plus 2x gives me 3x. And -6 plus 2 gives me that -4. I'm then going to take it one step further, and I'm going to factor my numerator, or try to factor my numerator, okay? So that gives me x plus 4 and x minus 1. Now, with previous examples that we've done, we can simplify this by canceling out this x minus 1 in both my numerator and my denominator. The only thing that you want to think about is before you cancel anything, you want to think about your domain, okay? Your domain in this case is x is all real numbers except -1, +1, and +2. But then I can go ahead and cross out that x minus 1, and I'm left with x plus 4 over x plus 1 times x minus 2. Again, you can leave it in this factored form. That's perfectly acceptable and fine. Or you can go ahead and FOIL through and multiply through and get the x squared minus x minus 2 for your denominator. Subtract rational expressions. So just like adding rational expressions, if you have like denominators, you can leave the denominator alone and just subtract. Just make sure you're distributing that negative sign to everything in that second fraction. Okay. So what is the difference between x plus 1 divided by x squared minus 6x minus 16 and x plus 1 divided by x squared plus 6x plus 8? So just like with previous examples, I need to factor my denominators. Okay. X squared minus 6x minus 16 is x minus 8 times x plus 2. X squared plus 6x plus 8 is x plus 2 times x plus 4. Okay. Again, I'm going to find my LCM, my least common multiple. I have that x minus 8. They both have an x plus 2 in common and an x plus 4. I multiply the LCM by each of my fractions. And then I multiply my numerators together. So again, I did that x times 4, 1 times x, 1 times 4. I did the same thing on my other fraction. Now, again, with this step, you want to make sure that you distribute this negative sign to each of the terms in that numerator of the second fraction, okay? So I want to make sure I get that minus x squared plus 7x plus 8 when I go ahead and try to add or subtract these from each other. So again, I combine my numerators, x squared cancel out. 5x plus 7x gives me that 12x, and 4 plus 8 gives me positive 12. So I simplify. I can factor a 12 out. So I get 12 times x plus 1. It doesn't really help me a whole lot because I don't have anything in common in my denominator to cancel it out with. But I will have a domain of all real numbers except x can't be 8, -2, or -4. Find a rate. Leah drives her car to the mechanic, then she takes the commuter rail train back to her neighborhood. The average speed for the 10-mile trip is 15 miles per hour faster on the train. Find an expression for Leah's total travel time. If she drove 30 miles per hour, how long did this take? So the first thing that we need to do is figure out her total travel time. We can remember that distance equals rate times time. So time equals distance divided by rate. So basically all this is I'm dividing my rate by my distance to get time by this equation. I can then create a table. So my car travels a total of 10 miles. I don't know the speed at which my car is driving, and I don't know my time. So 10 divided by R. My commuter rail or the train is still traveling 10 miles. It's traveling 15 miles per hour faster than the car is. So R plus 15. So I get 10 divided by R plus 15. So the total time for the trip is the car plus the commuter rail. All right, so what I'm going to do is I'm going to add the time it takes for my car plus the time it takes for my commuter rail and add them together. They don't have like denominators, so I need to find a common denominator. So my LCM is R times R plus 15. And I multiply that by my first and my second fraction. Okay. So that gives me 10 times R plus 15 plus 10R, which is 10R plus 150 plus 10R, which is 20R plus 150. Right. Now that we have a simplified version, we can substitute 30 miles per hour in the rational expression for R and solve and simplify to find the time. So again, I'm going to substitute that 30 in. So 20 times 30 plus 150 divided by 30 times 30 plus 15 is going to end up giving me 750 divided by 1,350. I can then divide both my numerator and denominator by 150, which gives me 5/9. To determine the time in minutes, I divide 5 by 9. So 5 divided by 9, and then I multiply that answer by 60, which gives me about 33 minutes. So 5/9 is about 33 minutes of an hour. Simplify a compound fraction. A compound fraction is in the form of a fraction that has one or more fractions in the numerator and or the denominator. How can you write a simpler form of a compound fraction? So I have 1 divided by x plus 2 divided by x plus 1, all of that divided by 1 over y. Okay, so there's two different methods. Our first method is to find a least common multiple, or LCM, of the fractions in the numerator and the denominator. Multiply the numerator and the denominator by the LCM. Okay, so I need to find the LCM, which is x times x plus 1 times y. And then I need to multiply that fraction, that compound fraction, by that LCM. Okay. When I do this, I can then divide out like terms. So in this case, I have x's, x plus 1s, and y's. Okay, I can then distribute. All right, so then we're going to go ahead and continue to simplify this fraction. So I've got x plus 1 times y plus 2xy divided by x times x plus 1. Again, I'm going to distribute that y. And I'm going to simplify. So I get 3xy plus y divided by x squared plus x. And I can leave it like this unless I can see if there's anything that I can factor out. In this case, there's nothing I can factor out, so I can either leave it as the 3xy or the y times 3x plus 1. Either is correct. Method 2 is to express the numerator and denominator as a single fraction, then multiply the numerator by the reciprocal of the denominator. So I'm going to multiply the numerator by the LCD, the least common denominator. So in this case, I'm literally just multiplying my denominator of my first fraction by the denominator by the entire fraction. Step 1, multiply. Step 1, multiply the numerator by the LCD. So I'm going to take my first fraction and multiply it by the denominator of my second fraction in my numerator. Okay, and I'm going to take my second fraction and multiply it by the denominator of my first fraction in the numerator. Okay. I can simplify that. Okay, which gives me 3x plus 1 divided by x times x plus 1. Now I have a compound fraction with just a single fraction in the numerator and a single fraction in the denominator. So I can treat this like I'm dividing two fractions. So I can multiply by the reciprocal. I keep my first, change my division sign to a multiplication, and flip my second fraction, and then just multiply straight across like I did with multiplying. I can simplify it, and I see that it's going to give me the exact same answer that I did previously. Again, either method works. It's completely up to you which version you want to use. Summary. Okay. So when we're adding and subtracting rational expressions, it's no different than adding or subtracting fractions. We're looking to see if we have a common denominator. If we don't have a common denominator, we need to come up with a common denominator, either using the LCD, the least common denominator, or finding the LCM, the least common multiple. Okay. Either way will work, and either way will give you the answer. You then want to add or subtract. Make sure when you are subtracting that you're going to distribute that negative sign to everything in your next fraction. And then you want to reduce as much as possible. Remember that before you reduce, you want to look at your domain and make sure that you list the domain. Compound fractions. A compound fraction is in the form of a fraction that has one or more fractions in the numerator and or the denominator. There's two methods to solving compound fractions. The first is finding the LCM. And then the second is expressing the numerator and denominator as single fractions. And that is the end of Unit 4, Lesson 4.